Okay, let's go ahead and start. So, uh, it looks like for the most part our exam went well, which I'm happy to see. Uh, One or two hiccups, and those things are being taken care of. So, if you're one of the people who had trouble, you know who you are, and we're just going to be working on that. I'll be sending out another email to those people later on today. But for today, I want to go over the exam and see some of the places that maybe we needed a little bit more work. All right. So, number one. Oh, and before I get into these too much, my understanding is that Hawks kind of chooses questions from a question bank to give to you for each of the questions on the exam. So, like number one, you might not have the exact same question, but it'll be the same content. So, same idea, maybe different numbers. Okay, so number one, we have 7 times 3y minus 7 equals negative 22 times 5 minus y. All right. So here we have an equation with variable on both sides. Nothing too crazy though. We don't have any quadratics or anything like that. This is just a normal little linear equation. So what we want to do here is say, all right, we've got parentheses, and we want to make sure that we get those parentheses broken open so that we can get to the numbers inside. So we're going to need to use our distributive property to do that. So first thing is 7 gets distributed into here, and 22, negative 22, is going to get distributed into here. Okay? So the 7 times 3y is going to give us 21y. 7 times negative 7 is negative 49. Then on the other side, negative 22 times 5 is negative 110. And then negative 22 times negative y is positive 22y. All right. So we've got those parentheses out of the way. Now we should check and see if there's any other ways that we can simplify these expressions. Well, lucky for us, I actually don't see any way that we can simplify these any further. There's no powers to take care of. There's no combining like terms that we need to do. These are already simplified. So now what we need to do is pick a side to put y onto. Again, we want to get y to one side and then get it by itself. So I'm going to say let's put y on this side. So minus 22y here. Minus 22y. That cancels here, but on this side, 21y minus 22y is going to give us negative 1y. Then, of course, the negative 49 is going to drop down. And the negative 110 is going to drop down. Okay. So now we need to get the constants to one side. And again, by constants, what I mean is any number that is just a value. It doesn't have a variable on it. So 49 and 110, those are our two constants. Since I put y on this side, I'm going to want to take the constant values and put them on this side. So that negative 49, we're going to need to move that by adding it. Okay, and I believe that comes out to 61. So cancels here. We get negative 1y equals negative 61. Then there's actually another step here, and that is I need to get negative 1 off of the y. So if it's multiplying by y right now, I need to divide it off. So y is going to be by itself since those two cancel. And then negative 61 divided by negative 1 gives us just positive 61. So there's our answer. Okay, so like I said, again, just normal little linear equation. Nothing too crazy going on. So let's move on. All right, number 2. We were given 6w plus 5 equals 6 times w plus 2 minus 7. So once again, just a linear equation, nothing too crazy going on. So like before, we have parentheses in this one, and we want to make sure that we get those parentheses cleared out. So same first step, we're going to use our distributive property. So 6 is going to go into that set of parentheses there. So we get 6w plus 5 is equal to, well, if we distribute 6 in here, 6 times w is 6w. And then 6 times 2 is 12. Then drop down the minus 7. Okay, so parentheses cleared. So now we need to check and see if there's any way that we can simplify these any farther. And yeah, this time there actually is. 6w plus 5, it's fine. Nothing to do there. Here on this side, though, we have the 12 and negative 7. And those two can combine since they are like terms. So if we combine those, we get 6w plus 5 equals 6w plus 5. That 12 and negative 7 give us positive 5. So this is one of those things that we were talking about when we were talking about our 3 types of equations. Again, we can have conditionals, which is where x is some number. You know, as long as it is this number, it'll make this thing work. It's the condition. Then we have contradictions where there can't be any number answer for x at all. And then this one right here is an identity, because we have one thing exactly equal to itself. 6w plus 5 equals 6w plus 5. So if we were to continue to solve this, let's see, so like subtract 5, and then subtract 6w, we would get 0 equals 0. So another way of saying that is that w can be all real numbers which we use the double R symbol there. So once again, W can be all real numbers, and that is because this is an identity. Okay. So let's go on to number 3. Number 3, a little bit of a change of pace. Instead of having a linear equation, we have a linear inequality. So here we have 3z minus 2 is greater than or equal to 3 plus 5z. So again, not an equation, an inequality. Now, remember that we solve these basically the same way. We just move things around until we get that variable by itself. But there is that one little extra thing that we have to keep in mind, and that is if we divide by a negative or multiply by a negative on both sides, we're going to have to change that inequality. We're going to have to flip it around. So let's see if that happens here. I'm going to keep z's on this side and constants on this side. So that means I'm going to need to subtract 5z, subtract 5z. Cancels on this side, gives me negative 2z on this side. Then this negative 2 drops down, and 3 drops down. Okay, so we haven't multiplied or divided by negative yet, so I can keep this inequality same direction. Alright, so now I need to get my constants to this side, so I'm going to add 2 to both sides. Cancels there. Here it gives us 5. So negative 2z is going to be same thing. We haven't divided by a negative yet, or multiplied by a negative. 5. So still got that greater than or equal to symbol. However, now we need to get that negative 2 off of z. And if this is negative 2 times z, the opposite of that would be divide by negative 2. So now we actually are going to be dividing by negative on both sides. So divide by negative 2, divide by negative 2. That's going to give us z is less than or equal to 5 over 2, negative 5 over 2. Okay. So, like I said before, gotta keep in mind that these work mostly the same way, except for that one little part where if we multiply or divide by negative on both sides, we need to flip that inequality. Now, the second part of number 3 tells us to graph that solution set. So we're going to need a number line here, which was provided on Hawks. Negatives on this side, positives on this side, 0 in the middle. So negative 5 halves, if we were to put that into a calculator or convert that to a mixed number, we'd see that that's 2 and 1/2, negative 2 and 1/2. So, you could put that onto your number line on Hawks. But I'm just going to say that negative 2 and 1/2 is about right there. Okay, so now we need to say whether we can be equal to it or not using either an open circle or a closed dot. Well, we can be equal to it because of that line underneath our inequality. So we're going to use a closed dot to show that we can be equal to this. Then z is everything smaller than negative 5 over 2. So our line is going to extend over here. And there's our graph. Okay. So that's it for number 3. So I'll go ahead and pause here. Let's see if I can zoom out a bit so we can see all of these that we've gone over so far. And if we have any questions, please let me know. Okay, I don't see any questions, so we will move on. Okay, number 4. It says solve the following quadratic equation by factoring. Okay. So, number 4 gave us 16x squared. I'm sorry, no, y squared. Not that it makes a difference. Minus 81 equals 0. Okay. So anytime that we encounter one of these things, we want to go through our little list and see what ways we can factor this. So first of all, can we use my goodness, I just went blank. Can we factor out a common factor? Can we use GCF factoring? There we go. Well, 81 is 9 times 9, which 9s are both 3 times 3. So 81 can be divided by either 3 or 9. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. Yeah, I don't see any common factors there, so we can't do that. Is this a difference of squares then? Yes, actually it is. So if we look, 16 is 4 squared. Y squared is literally Y squared, and 81 is 9 squared. And yes, indeed, they have a difference between them. They are subtracting. So we can factor this as a difference of squares. Okay, so with the difference of squares, we know that we get two factors out. We take the square root of all these numbers. So square root of 16, like I said, is 4. Square root of y squared is y. Square root of 81 is 9. And that fills into our two factors here. And then one of them will be minus in the middle. One of them will be plus in the middle. Because, as we know, a difference of squares will always factor down to conjugate binomials. And conjugate binomials means one of them's got negative, one of them's got positive. And so this is still equal to 0. All right. So now that we've got this factored, we no longer have the y squared thing, which is really the reason we can't solve this normally. I mean, we can, but it gives us some problems. Okay, so what we can do instead is we can use our zero product principle, which tells us if we have two things that are multiplying, so this factor is multiplying by this factor, and it gives us 0, then both of these things could be 0. So 4y minus 9 could be 0. And 4y plus 9 could be 0. And now we just need to solve. So this one, move 9 to the other side, we get 4y equals 9. Divide by 4 on both sides, we get y equals 9 over 4. Here, same thing, move 9 to the other side, we get 4y equals negative 9. Divide by 4 on both sides, we get y equals negative 9 over 4. And there's our two answers. Okay, so let's go ahead and move on. Number 5. We're given... Ooh, weird. We're given x minus 6 squared equals 16. Okay, so this one's pretty simple. Again, we've got the problem of having that set of parentheses there, and we really want to get into those numbers inside of those parentheses. So we're going to need to take that square off in order to get into them. So to take the square off, we square root, and we're going to have to do that to both sides to keep balance. So that eliminates the square here, giving us just x minus 6. Then on this side, we have, again, the square root of 16. Now, remember, when we take the square root of something like this, we need to say that it's not just the positive, which positive 4, but also the negative. So this is going to be plus or minus, because it could be either one. And then, to get x by itself, we add 6 to both sides. So x equals 6 plus or minus 4. Okay. Well, let's actually figure out what that is. So, x could be 6 plus 4, which is 10. But x could also be 6 minus 4, which is 2. And there's our two answers. So again, I'll take a quick pause here to see if we have any questions over the ones we just went over. Yeah, that's it. All right, let's keep going. Whoops, too far. Okay, so next one, number 6. Says solve the following quadratic equation by completing the square. Okay. So it gives us y squared plus 14y plus 33 equals 0. Okay, so completing the square. Remember that this is the method where we kind of force this thing to be something that we know how to factor. And the first part of that is making sure that our leading coefficient, the number out here in front of y squared, is positive 1. And yes, it is. It is positive 1. So good to go there. Next step is to get just the y's by themselves. So we'll need to subtract 33 from both sides. That's going to cancel on this side, leaving us just the y's. So y squared plus 14y equals negative 33. Okay. Next, we need to actually make this a perfect square trinomial. And the way we do that is we take half of this number, 14, and square it. So half of 14 is 7. 7 squared is 49, so we will need to add 49 to both sides. So y squared plus 14y plus 49 equals negative 33. Goodness. Plus 49. Okay. So now we need to go ahead and add this together and factor this. I'm going to do that in one step just to save time and space here. So this is now a perfect square trinomial because this number right here is half of this one squared. So we know how this factors. We take this variable, drop it down. Take this sign, drop it down. And take half of this number, drop it down. And then that whole thing is squared. This side, we just need to combine those like terms. So 33, negative 33 plus 49, that's going to give us 16. Okay. So now we have this in a form that we can actually solve. So first things first, we need to get these parentheses out of here, and we do that by getting rid of the square. So take the square root of both sides. That's going to give us y plus 7 equals, square root of 16, like we said before, is not just 4, it is plus or minus 4. And then take 7 away from this side to get y by itself. And we get that y could be negative 7 plus 4 or minus 4. Okay, so let's actually figure out what that represents. So y equals, okay, if we have negative 7 plus 4, that's going to be negative 3. If we have negative 7 minus 4, that's going to be negative 11. And there's our two answers. Okay, so let's move on. Number 7 says solve the following quadratic like equation. Okay, so this one we're given z squared minus 1 squared minus 10 times z squared minus 1 plus 16 equals 0. All right. So this one, the thing about it is that it's kind of like a quadratic right now. We do have these repeated factors that are repeated terms. That is, z squared minus 1 is repeated here and here. And so what we can do to make it a little bit easier on ourselves to solve this is to replace this with something. I use m. So I'm going to say m equals z squared minus 1. So m squared minus 10 m plus 16 equals 0. So now this thing is definitely in the form of a quadratic, and we know how to solve these by this point. So we can either use AC method, complete the square, whatever we want to use. Okay, I'm going to try AC first. So my A is 1, my C is 16, giving me an AC of 16. So factors of 16 are 1 and 16, 2 and 8, 4 and 4. So, will any of these give me 10 if I combine them? Yeah, 2 and 8. If I make this negative 2 and negative 8, those will multiply to get positive 16, but combined give me negative 10. So yeah, I can go ahead and keep on using this method here. So next I'm going to draw up a box for my box method. And first term goes in the first box, so m squared goes in here. Last term goes in last box, 16. Doesn't matter which one of these goes which place here. I'm going to go ahead and put negative 2m here and negative 8m here. Now I just need to find the common factors for my rows and columns. So here I can take out an m. Here I can take out 8. Here I can take out m. And here I can take out 2. Meaning that my two factors are m minus 2 and m minus 8. And so that now equals 0. Then we can use our zero product principle to say that either of these factors equals 0. So m minus 2 equals 0, or m minus 8 equals 0, and solve each of them, meaning that m could be 2 or 8. Okay. So remember that this does not mean that we have our answer. It just means that we know what m could be. And we said that m is equal to z squared minus 1. So we now need to say z squared minus 1 could be equal to 2, or z squared minus 1 could be equal to 8. And solve each of these. So take 1 to the other side. By adding it, we get z squared equals 3. Take the square root of both sides, we get that z could equal plus or minus the square root of 3. Here, same thing. So add 1 to both sides, we get z squared equals 9. Take the square root of both sides, we get that z equals plus or minus 3. And there's our 4 answers for this one. So z could be positive square root of 3, z could be negative square root of 3, z could be positive 3, z could be negative 3. Okay. So I will pause for questions. All right. I'm not seeing any questions, so I'll move on. Make sure. Okay, good. So next one, number 8. Actually, basically the same thing as what we just did. So it again says solve the following quadratic-like equation. So we have y squared minus 7 squared plus 6 times y squared minus 7 minus 16 equals 0. So just like the other one, the idea here is that this one is kind of like a quadratic right now, but we can make it more like a quadratic if we replace these repeated terms with m. So I'm going to say m equals y squared minus 7. So replace them with m squared plus 6m equals, minus 16 equals 0. All right, so let's go ahead and solve this one. And let's see. Yeah, let's try out AC method. See if that'll work. So we've got 1 here, negative 16 here. 1 times negative 16 gives us an AC of negative 16. So we have factors 1 and 16, 2 and 8, and 4 and 4. And we need a pair that's going to give us positive 6 when we combine them, so that'll be negative 2 and positive 8, because negative 2 times positive 8 is negative 16, but negative 2 plus 8 is positive 6. Now, when we were doing this one up here, you might have been smart and you said, Mr. Hardison, we didn't need to do the box method here because we have a leading coefficient of positive 1. You're absolutely correct. Because we have a leading coefficient of positive 1 here, once we get these two factors, we can just fill them in to our factored form. So our negative 2 went here, our negative 8 went here. Same thing here. So we have a leading coefficient of 1, meaning that we can take our shortcut and say these two numbers here filter into our factored form. So I'm actually going to skip the box method here. Don't need it. I was just doing it before for practice. So our two factors are m minus 2 and m plus 8 equals 0. Okay. So now we just need to use our zero product principle to solve these. Again, each of these could be equal to 0, and that means that m could be equal to 2, or it could be equal to negative 8. All right. Again, we're not done yet, though, because this is just m. We want to know what y is. So if m equals y squared minus 7, then that means that that means that y squared minus 7 could be equal to 2, or y squared minus 7 could be equal to negative 8. Okay, so add 7 to both sides here. That's going to give us y squared equals 9. Take the square root of both sides. It's going to give us y is equal to plus or minus 3. Take 7 to this side. That's going to give us negative 1. Y squared equals negative 1. Then take the square root of both sides. That gives us y is equal to the square root of negative 1. Plus or minus the square root of negative 1. Now, what is the square root of negative 1? I. So plus or minus I. And there's our 4 answers. Okay, so let's keep on going. Next one, number 9, gives us a rational expression. So the expression it gives us is, 3x squared minus 8x minus 35 all over x squared minus 8x plus 15. And it wants us to do two things here. First, it wants us to simplify the expression. But the other thing it wants us to do is find any excluded values. In other words, find the domain of x. So what can x be? What can it not be? And the way that we determine that is we say that the bottom part, no matter what the bottom part is, this whole thing cannot come out to be 0. Okay, so I'm going to go ahead and start by factoring both of these expressions here. Alright, so let's see. Try the AC method with it. So 3 times 35, or negative 35 is negative 105. And factors of negative 105. Let's see. So 3 would work, but that's probably not going to get us anywhere. Uh, 7 and 15? Yeah, that'll work. So if we make this 7 and 15, and in order for us to get an 8, we'd need to have, or a negative 8, we'd need to have a positive 7 and a negative 15. Now this one, we can't use our shortcut because we don't have positive 1 for our leading coefficient. We have 3. We have positive 3. So we're going to actually have to go ahead and use the box method here. Fill in our box. So first term goes in the first box, 3x squared. Last term goes in the last box, negative 35. Then I'll put 7, positive 7, x in here, and negative 15, x in here. Okay, so now we need to figure out what can come out of each row and column. So this row, only x. This row, 5. This column, we can take 3 and x. This column, we can take 7. Okay, so our factored form for the top part here is 3x plus 7 and x minus 5. Okay, now we need to figure out the bottom part. So same thing, we're going to need to factor that bottom part. And since I'm running out of space down here, I'm going to go ahead and erase this. Excuse me? Okay, I've got another way to do this. Whoa, okay. And yeah, there we go. All right. So, bottom part, x squared minus 8x plus 15. We can go ahead and factor that. Again, use AC method. So 15 is our AC. We can get factors out of that of 1 and 15, 3 and 5. 3 and 5 will give us 8 if we combine them, making that negative 3 and negative 5. And since we have a leading coefficient of positive 1, we don't need to use the box method. We can just use these for our factors. So, factored form, x minus 3 and x minus 5. There we go. Now again, it wants us to not only simplify the expression, but also give any excluded values. So before we go any further, let's find those excluded values, since now it's a lot easier to find since this is factored. So, like we said before, whatever's on the bottom does not matter what is on the bottom. We cannot have it be equal to 0. So we say that this bottom part here, x minus 3, times x minus 5 cannot be equal to 0. And we now have our zero product principle again. So both of these cannot be equal to 0. And if we solve that, then we get that x cannot be equal to 3 or 5. So those are our excluded values. Okay, now to simplify this thing all the way, we find anything common between top and bottom. X minus 5 is common, so those will cancel. And we just are left with 3x plus 7 over x minus 3. And so there's our simplified form. There's our excluded values. And I will give us a few minutes here to ask any questions. I am going to erase all of this in a moment so that I can use this space for the rest of the questions. Okay, Victor asks, what if the answer comes as a fraction? Okay, now do you mean the excluded values, or do you mean the this right here? Because excluded values, yeah, you might get a fraction. That's perfectly fine to get a fraction. It's just kind of nice that we got nice little integers here, but you might get something like, if there was a 2 in front of here, oh my gosh. If there's a 2 in front of here, then if you solve this, that'd be 2x minus 3 is not equal to 0. You would take 3 to the other side, then divide by 2, and you'd get x is not equal to 3 over 2. And that's perfectly fine. You can get a fraction. It's going to be a fraction basically no matter what. It's very rare that everything is going to cancel out. So does that answer your question, Victor? Previous problem, okay. So previous problem, same thing. It's perfectly fine to get a fraction. So like if you're solving either this part, so the m minus 2, m plus 8, and you get a fraction, again, that would come if you have a coefficient in front of m here. So if you have a coefficient here and you solve, yeah, you're going to get a fraction. Same thing with this solving. You might get a fraction, and you might have to take the square root of a fraction. That's perfectly fine. If you get a fraction, you just get a fraction, man. But it's perfectly fine to get a fraction for any of these answers. And I believe that one of the problems in the solution pool, in the question pool, was going to give you a fraction. And you might get something like, I don't know, 25 over 16 here, and then take the square root of both sides, so that would give you 5 over 4. Again, that's fine. Does that answer your question? Does that answer your question, Victor? Okay, I'm not getting an answer from Victor, so I'm hoping that does answer his question. Okay, next one. Number 10. So, very similar, only a very small difference with this one. Again, it gives us an expression that's a rational expression, and it gives us z squared minus 12z plus 32 over z squared minus 16. Okay, so just like before, we want to simplify this and find any kind of excluded values. So again, like before, we want to factor the top and factor the bottom and see what that comes out to be. Luckily, these are actually pretty simple to factor. I've got a leading coefficient of 1 on this one, so we can actually use our shortcut method with it. We just need to find that AC and then fill in the blanks. So our A is 1, our C is 32, so our AC is going to be 32. And then we need to find factors of 32 that are going to give us negative 12 when we combine them. Okay, so 32. 32 is... 2 and 16. Then we could have, let's see, 8 and 4. And I think that'll do it. So if we make both of these negative, negative 8 and negative 4, negative 8 plus negative 4 is going to give us negative 12. Negative 8 times negative 4 is going to give us positive 32. So yeah, that'll work. And like I said, since we have a leading coefficient of positive 1, we can go ahead and just use our factors. We don't need to go through AC. So we have Z minus 8 and Z minus 4. Again, negative 8 filters in there, negative 4 filters in there. Bottom part, excuse me. We have Z squared minus 16. And the fact that there's only two numbers here, two terms, should be a tip that we can either use GCF factoring or use the difference of squares factoring. Well, I don't see a GCF between Z squared and 16, so difference of squares? Yeah, they are. Z squared is literally Z squared. 16 is 4 squared, and this subtraction between them shows difference. So this is a difference of squares. So we can factor it as a difference of squares, which means that it comes out to be conjugate binomials. Z minus 4 and Z plus 4. Okay. So before we simplify this rational expression, now that it's factored, we should find our excluded values, since it's easier to do now that it's factored. So, like I said before, on the bottom, doesn't matter what that bottom part is, this bottom part cannot be equal to 0. So we say Z minus 4. Let's not put parentheses around it. Z minus 4 cannot be equal to 0. And Z plus 4 cannot be equal to 0. Which means that Z cannot be equal to 4 or negative 4. So there's our excluded values right there. Okay, then for simplifying this thing, again, we need to find anywhere that we have common terms between top and bottom. So Z minus 4 and Z minus 4 are common. We can cancel those out, and we'll just be left with z minus 8 over z plus 4. And there's our simplified form. So there's the two parts of this question. So any questions before I delete this? Okay, I'm not seeing any questions, so I will move on. So let me back this up. Okay, last question, number 11. We are given square root of 144 minus x minus x equals 12. Okay. So, I really don't want that square root hanging around. It's giving me problems right now. So, let's go ahead and try and get rid of it. Now, before we get rid of it, we need to get that x to the other side, because we just want that square root by itself. Basically, what I want to do here is be able to square both sides to get rid of that square root. So I'm going to add x to both sides, which leaves me with the square root of 144 minus x equals 12 plus x, or I'm just going to write it as x plus 12. Okay, so now that I have that square root by itself, I can go ahead and square both sides. So I'll square that side, square this side. That will cancel out my root here, giving me 144 minus x. Equals, well, I need to square this out. So let's see, x times x is x squared. That's an ugly looking x squared. That's not better, but whatever. Then x times 12 and 12 times x both give me 12x. That's 24x. And then 12 times 12 is 144. Okay. So now I can start moving things around and trying to get something that I can solve. Now, what if one of the excluded numbers turned out to be a fraction? Again, if an excluded number turns out to be a fraction, that's perfectly fine. It really doesn't matter if it's a fraction or an integer or something like that. Excluded values can be anything. They can be integers, so just normal little numbers. They can be fractions. They can be non-real numbers. They can be roots. They can be all sorts of different numbers. So excluded numbers, it's perfectly fine for them to be a fraction. Okay, so I want to get this into something that I can solve. So what I see right now is that I have a quadratic here. And I like for my quadratics to be equal to 0, so I'm going to take everything from this side and bring it over here. So minus 144 and plus x. Both of those cancel over here. Again, I'm going to do plus x and minus 144. And so that's going to give me, I'm going to rewrite it up here, x squared plus 25x well, that also cancels, so plus 0, which I'm not going to write that, equals 0. Okay. I'm not sure what you're asking with that latest message, Victor. So excluded values. So like I said, the excluded values are just the numbers that we can't plug in for x because it'll make the bottom part equal 0. Okay, so it really doesn't matter what type of number that comes out to be. It could be any kind of number. There's any kind of thing that we could plug in for x and make the bottom part equal to 0. We can't have that. So if your excluded value comes out to be a fraction, that's fine. Okay. So again, we've gotten down to this. Okay. Now, can I factor this? Against a quadratic, can I factor it? Well, it's not a difference of squares. It's almost there. It's real close to being a difference of squares. Not quite there, though, because we don't have a difference, and this isn't perfectly a square. We could use AC method here. If we recognize that this value over here is 0, kind of makes things weird, though. However, there's something way easier, and that is to recognize that both of these have x. So we can actually use GCF factoring here. We can factor an x out. So make this x times x plus 25 equals 0. Okay. And now, again, if we look closely here, we see that we have x times x plus 25. Well, this is two things multiplying to get 0. So we can use our zero product principle. Set both the things that we're multiplying equal to 0. So the first thing we're multiplying is x. Set it equal to 0. Hey, that's easy. X equals 0. Then the second thing that we're multiplying is x plus 25. Set that equal to 0. Solve. And we get that x is equal to negative 25. And so there's both of our answers. So I had to use a little bit of extra logic here. Again, we had to kind of force this to fit into a form that we could maybe solve, and then go ahead and use that zero product principle. So this one is extra credit. Now, Hawks didn't grade it as extra credit because I kind of forgot to say that to Hawks. Okay, thank you. Yeah, I kind of forgot to tell Hawks to grade this one as extra credit, so I will be going back and fixing scores. But yeah, this one need a little bit of extra work on it for us to maybe get to the answer, so I made it extra credit. Okay, any questions on this one then? So I've just been informed that Victor's having some delays, so I will leave a little extra time on this one, just in case he has any questions. Okay, while we are giving a little more time, I will say that remember that Mr. Merzinski is giving, I believe, a test today. And the things that you can expect to see on his test will be the same things that were on my test, just a little more complicated. So my test should be pretty good practice for what you'll see on his. And again, it'll work the same way as mine. You should need to sign a honor code agreement and then take the test on Hawks. That's what I've understood is the system that Mr. Merzinski has in place for his tests. So that's why I followed it for my test. Okay. So again, like I said, basically same questions, just they'll be a little bit higher level, maybe bigger numbers or one or two extra steps that you might have to use, but same ideas. Okay, and like I said, those of you who were having problems yesterday with the test and getting into it and whatnot, I will be getting to you with some emails, and hopefully we'll get things figured out and get you into that test. I think that'll do it for today, though. I'm not seeing any questions. So I will see y'all on Friday, and we'll be starting some new stuff then. Oh, and just so you know, I don't know if any of y'all are still in Alpine. I think all of y'all are out. But Alpine has officially gone into shelter in place. So stay away from Alpine if you are out of it right now. My understanding is that some individuals flew into Marfa who could possibly have been infected. And so we're just going to keep on trying with this distance learning thing. Not really much we can do now. Okay? So I will see y'all on Friday. Hopefully this all eventually gets fixed. And hopefully it happens soon. But yeah, for the foreseeable future, we're just going to have to keep doing this for the entire semester. All right. So I'll see y'all later. I hope you have a good day. Goodbye.